Hello students, today we will start our 8th experiment, and the aim of the experiment is parallel operation of two alternators. The apparatus required are alternator, it is 5 kVA, 400 volt, 3 phase, 50 Hz, and the quantity required is 1 incandescent lamp, 100 watt, 230 volt, 50 Hz. The quantity required is 2 voltmeter MI type, 0 to 500 volt, 50 Hz. Ammeter is moving iron type, 0 to 25 ampere, 50 Hz. Frequency meter, 45 to 50 Hz, 440 volt. Phase sequence indicator, 440 volt, 50 Hz, 3 phase. Combination plier, screwdriver, electrician knife. We also require a neon tester, connecting wire as per required, or 25 meters, whichever is convenient to you. Now the theory. The operation of connecting an alternator with another alternator or with common bus bar, known as parallel operation of synchronization of alternator. There are several conditions for synchronization, or there are several methods for synchronization. The first one is the terminal voltage, or the RMS value of the incoming alternator must be same as busbar voltage. Generally, voltage of both generators can be adjusted to by changing the field excitation. So students, by changing the excitation, we can change the generated EMF. The second condition is the frequency of generated voltage of the incoming alternator must be equal with the bus bar frequency. Now, frequency of alternator can be adjusted by changing speed of prime mover. The third condition is the phase sequence of voltage of incoming alternator should be same as that of bus bar phase frequency checked by sequence indicator. So there are two methods for synchronizing of alternator. Rather, there is also another method, but in your course you have two methods, so we will discuss about the two of these methods. The first method is by 3 lamp method, that is 1 dark 2 bright method. The another is by synchroscope method. So student, by this two method we can bring two alternators in parallel operation. So what are the procedure? The lamp L1 is connected between R1 and R2. So before that, let us have a look to the diagram. So this is the diagram for 1 dark 2 bright lamp method. As you can see, there is an existing alternator and a incoming alternator. The left hand side of your screen is the existing alternator, the right hand side of your screen is the incoming alternator. Here we have lamp L1, L2 and L3, as well as there is a voltmeter. So we will now continue the procedure. The lamp L1 is connected between R1 and R2. The other two lamps are connected across another two phases, that is between L2 between Y1 and B2 and L3 between B1 and Y2. Before synchronizing, all the conditions should be satisfied. Generated voltage of the incoming alternator can be adjusted through field excitation. Frequency of alternator can be controlled and made equal with busbar frequency by speed of prime mover. When all the conditions are satisfied, at that moment lamp L1 will dark while L2 and L3 will be equally bright. Because potential difference between R1 and R2 is same due to same phase, but other two are in opposite phase. At that instant, the TP ST switch of incoming alternator can be closed or connected to the bus bar. Now, required for parallel operation. What are the conditions required for parallel operation? Continuity of service, overall efficiency is increased, maintenance and repair of individual alternator can be achieved, initial installation cost is low. Now students, there is the observation table which has been shown for you for a single phase alternator. We have discussed about three phase alternators, but in the observation, as our lab has a single phase alternator coupled with a DC motor, so the parallel operation in your video was for single phase alternator. So accordingly we have noted the outputs which is in your observation table, so you have to note it down. So the voltage, generated voltage for the existing alternator was 220, the incoming alternator was set to be 220. How it was set? By adjusting the field rheostat, which you can clearly see from the video. Now the frequency of the incoming machine was 50 Hz and the frequency of the existing machine was also 50 Hz. Now the RPM. The RPM of the machine 1 or the existing machine was 2200 RPM and the incoming alternator was 2180. As per the theory, the speed of both the machines should be equal, but 10% difference would not make any difference, so we can tolerate this value. Now conclusion. From the above experiment, it is observed that two alternators share the given load according to their kVA rating. So on the basis of this experiment, we have some review questions for you. What is synchronizing? Why alternators rated in kVA? What are the conditions required for synchronization? What are the benefits of synchronization? What different methods for parallel operation of alternator? So this was all for your parallel operation of alternators. So you have to write this experiment. So thank you for watching, students.